Today I want to discuss about correlation and regression. Correlation or regression are two most common statistical analysis technique for especially social sciences. Also for sciences, they use this approach, but most common in social science disciplines. So actually, correlation is under bivariate analysis technique, because for correlation, two variables involved in analysis technique, right? But for regression, if we use simple regression is applied and used with the two variable, one independent variable and one dependent variable. But if we apply multiple regression, we will go to multivariate analysis technique. So these two, bivariate and multivariate, are we swap between these two for correlation and regression, right? Okay, first, correlation. Correlation is actually a procedure, as is an analysis technique that we aim to investigate, aim to examine relationship between two variables. We use a relationship word for correlation, because actually for correlation, the relationship between variables are bidirectional. So it means we don't have a specific direction for the effect of X on Y. X can influence on Y, or also Y can influence on X. So we don't have cause and effect. We don't have causal relationship in correlation. So correlation, two variables work together, two variables increase or decrease together. For example, height or weight. We want to see relationship between height and weight of our sample, right? We have 50 students from this school, and we want to see relationship between height and weight of students. Or, for example, we want to see a relationship between mathematics marks and physics marks. So we want to see if there is any relationship between mathematics mark and physics mark or not. Here, there is not any causal relationship. We don't say mathematics marks influence on or effect on physics mark. Or it's meaningless to say weight effect on height, right? So it's meaningless. So for this type of relationship, we use correlation. So correlation for some type of relationship that is bidirectional. X can affect on Y, and also Y can affect on X. So this is one actually characteristic of correlation. Another one, what's the meaning of correlation? Correlation is something that two variables vary together. Two variables change together. If variable one, if X increase, it means variable Y should increase or decrease. So by increasing one variable, we can see change in another variable. So by changing one variable, another variable will be changed. So this is the concept of correlation, right? Okay. So this is another characteristic of correlation. correlation actually is correlation is between -1 and 1, right? Okay, here before going to number, here I have some explanation about correlation. Here I explain loyalty and revisit intention and destination. Okay, but actually, if we investigate causal relationship between loyalty and revisit intention, so it is not correlation. If we want to test relationship, we want to test effect of loyalty on revisit intention, so it's causal relationship, it's not correlation, if we hypothesize. But if only we want to see a relationship between two variables, we don't want to see cause and effect. We don't want to see effect of loyalty on revisit intention. Only we want to see how these two variables change together. And what's the relationship between these two variables? This is correlation. So correlation, when we use correlation for hypothesis testing, our hypothesis should refer only to relationship between variables, not cause and effect. But sometimes we use correlation to check similarity of two variables, not for hypothesis testing, only for similarity of two variables, right? Yes, we can use correlation to check similarity of two variables and see how these two variables, how close are these two variables, how similar are these two variables. For example, loyalty and revisit intention, we measure these two variables based on some items. We want to see what's the understanding of our respondent about these two variables. They perceive these two variables very similar variable, or no, they have different understanding for these two variables. So in this case, we can apply correlation to check similarity of these two variables, not relationship, not hypothesis, right? So, okay. The value of correlation is between 1 and -1. So correlation 1 means two variables exactly are same. And very, very correlated. -1 is, -1, it means these two variables are exactly in different direction. If variable 1 change 1 unit, increase 1 unit, variable 2 will decrease 1 unit. So the direction is totally different. So correlation, the sign of correlation refer to the type of relationship. If two variables are related and increase together, so the correlation is positive. But if by increasing one variable, another variable decrease, it's negative correlation, right? If the correlation is 0 between -1 and 1, it's 0. 0 means there is no any relationship between these two variables. So correlation, range of correlation is between -1 and 1. -1 and 1 means high correlated, but 1 is positive and -1 is negative, and 0 is no correlation, means no correlation. Actually, the correlation comes from this formula. And this formula comes from covariance. Covariance is something, actually the relationship between two variables. You remember variance? Okay, let me show you. This is the formula for variance. When we work with one variable, the summation of x minus x bar is mean value of our sample, the power of 2 divided to n minus 1. This is a formula for standard variance. So variance show variation of different cases, different samples, between different cases in our sample. And this comes from standard deviation, variance. But covariance is, covariance here. This formula is for covariance. For covariance, we have two different variables, x and y. For variance, we have one. You can follow me for different pages, right? Now you can see my screen, right? When I go to different parts, different presentation, you can follow me, right?
Yes.
Yes.
So this is the formula for covariance, right? Okay, again, look at variance. Variance, we have one variable minus x bar. But for covariance, we have two variables. Summation of xi minus x bar. Multiply yi or yj minus y bar. So this is divided to n minus 1. So this is the formula for covariance. But the value of covariance can be anything. It depends on the value of x and y. But if we divide this covariance, to standard deviation of x and y, this will be correlation. So the value of correlation is between -1 and 1, because we divide covariance to variance of x and y. So the same here. This formula is similar to this one. Numerator is summation of x minus x bar and multiply y minus y bar. And here is from standard deviation. So this formula defines correlation between x and y. We call this Rxy as a correlation coefficient. And this correlation coefficient should be between -1 and 1. Interpretation, -1 is high correlated but negative. -1 is high correlated and positive, and 0 is no correlation. Anything between these values, it means if correlation is close to 1, for example 0.7, so it means correlation is high. If correlation is very close to -1, correlation is high but negative. But if correlation is very close to 0, means the correlation is very low. So correlation can be any value between -1 and 1. We have two methods, at least two different formula to calculate correlation. If our variable x and y are normal distributed, these variables are normal variables, so we can use Pearson correlation coefficient. So we use Pearson method to calculate correlation. But if x and y are non-normal, so we need to apply non-parametric method to calculate correlation. So Spearman rho coefficient or Spearman coefficient, correlation coefficient, is non-parametric method for calculating correlation for non-normal data. For non-normal data. But the interpretation is exactly same. We interpret based on size and sign, right? Based on size and sign. So this is the concept of correlation. What's the hypothesis for correlation? For correlation, null hypothesis is correlation coefficient equals 0, right? So it means when correlation coefficient equals 0, we have no correlation. And null hypothesis refer to non-existent of relationship. But if correlation coefficient is different with 0, if it's higher than 0, right, or lower than 0, it means this is alternative hypothesis. But we can have two types of alternative hypothesis, right? Based on positive or negative. Anybody can say how we can hypothesize. For example, I want to hypothesize the correlation between loyalty and revisit intention. But I want to hypothesize one tail. What should I say? Anybody can answer?
We should put it as there is a positive correlation between, or maybe there is a negative correlation. We have to specify the direction.
Yeah. Okay, good. When we want to say one tail correlation hypothesis, if based on the literature is positive correlation, we would say, okay, there is positive relationship or positive correlation between loyalty and revisit intention. But if we have, based on literature, we know the relationship is negative, so we say there is negative relationship or negative correlation between loyalty and revisit intention. But if we don't know, there is significant correlation between loyalty and revisit intention. So in the last one, we hypothesize correlation, two-tail hypothesis. But in former one, we hypothesize one tail when we say positive or negative, right? Okay, so this is the way that we hypothesize correlation and the relationship between and one tail and two tail hypothesis for correlation. So null hypothesis and alternative hypothesis for correlation is based on correlation coefficient. Equal 0 is null hypothesis, and unequal or different with 0 is alternative hypothesis. Okay, but for correlation, actually, if we hypothesize correlation, like before, we need to test and we need to report p-value, t-value, and confidence interval for correlation, right? If we want to test correlational hypothesis. But actually, most of the time, we interpret correlation based on size and sign. So for correlation, we need to look at all these things. If we have hypothesis, we need to look at the t-value, p-value, and confidence interval. And then we need to look at size and sign to understand the type of relationship. How strong is the relationship and what's the direction of relationship? Is it positive or negative? Based on Cohen, for correlation, we don't have effect size, but for the value of correlation, we can interpret the size of correlation. If the value of correlation is between 0.1 and 0.3, if it's lower than 0.1, is very close to zero, actually is not acceptable. It means no correlation. It's very close to zero, and the same interpretation with zero. If it's between 0.1 and 0.3 is small, 0.3 and 0.5 is moderate, and higher than 0.5 is large. For interpretation of moderation. So interpretation of correlation. So correlation higher than 0.5 means two variables are high correlated, have the high correlation. Between 0.3 and 5, moderate correlation, and 0.1 and 0.3, small moderation. So this is interpretation for correlation. Okay. So this is some basic things for bivariate correlation and interpretation. Let's go to,
Excuse me.
okay. So for correlation, for example, here, we already created two variables, community attachment and economic gain, right? So we want to see correlation between these two variables. Correlation between community attachment and economic gain. So we need to go to analyze and for correlation, correlate. So analyze, correlate, bivariate correlation. Click on bivariate. So this box, we need to transfer all variables that we want to check correlation. If we transfer two variables, only we can see correlation between two variables. If we transfer more than two variables, we can see correlation between different pairs, right? So now I transfer three variables: community attachment, economic gain, and positive perception. So I transfer these three variables and want to see correlation between these variables. Option, nothing to change. And okay, here we have three options. Second one is not common. First one and the third one, you can see Pearson here. If your variable is normal, if your variable is normal and you already checked the normality of your variable, so you can choose Pearson correlation coefficient. If your variable is not normal, you can choose Spearman, right? So now we assume that this variable is normal or normal. So we can choose Pearson. Here also you can use two tail and one tail. Two tail and one tail. Two tail, if you hypothesize this relationship, if you didn't hypothesize, doesn't matter, because you don't want to see the result of test. Only you want to see a relationship. But if you hypothesize based on your hypothesis, two tail or one tail, you need to select one of these. So here we have correlation table. You can click on this and transfer to your Word file. Right? Copy and paste. And okay, what's the interpretation? Here we have three different blocks. Three different blocks. 3 rows and 3 columns. Because we included 3 variables. So in each block, for example, first row, here you can see correlation between community attachment and the community attachment. So correlation between same variable always is 1, right? Because you have exactly same variable. So correlation is 1. So this is the correlation between community attachment and community attachment. Second column is correlation between economic gain and community attachment. And third one is correlation between positive perception and community attachment. So this is the size of correlation. Okay, what's the correlation between economic gain and community attachment? 0.293, right? 0.293. And correlation between community attachment and positive perception, 0.460. Okay, both are significant. This is p-value. This is p-value. Both are significant. But size of correlation between economic gain and positive perception with community attachment, size of correlation is moderate for both, right? Because it's between 0.3 and 0.5. Sign is positive. So you can see sign and size. Second one, economic gain. Economic gain and community attachment. So this value is exactly same as this value. Why? Because correlation doesn't matter, you say correlation between community attachment and economic gain, or correlation between economic gain and community attachment. Right? So here we have same value with this one. Both are 0.293. Economic gain and economic gain is 1. Economic gain and positive perception is 0.304. And both are significant, but the value are moderate, right? And the last one, positive perception and community attachment. This one is similar to this one. Exactly same, because here is community attachment and positive perception. Here is positive perception and community attachment. And this one is same as this one. Right? So we have correlation and size, sign, and the significance of correlation, p-value here.